Good morning, everyone. So my name is Martin Brown. I'm a software group manager at Ettus Research. So I'm also the Martin Brown on the GNU Radio Foundation side, but here I'm going to talk about what we do at Ettus Research. And I titled my talk Ettus Research and its research as a bit of an obscure reference in there. I don't know if anyone caught it or picked up on that. But someone said yes? No? So I'll resolve it in a sec. OK, so I decided to keep this talk technical, keep it about usurps and Ettus Research stuff. But I didn't want to go into too many inspirational quotes because this is not a keynote. But I actually do like my inspirational quotes every once in a while. They help me prepare slides for conferences. And for a long time, this is like actually a burrito bag. And I actually had this in my cube for a long time. And I replaced life with SDR, which in my case is actually pretty accurate. And this is about, are you actually working on the right kind of thing? But the person who most succinctly framed that specific question, are you working on the right stuff, is, in my opinion, Richard Hemming, who gave a very famous talk called You and Your Research, which is where my title came from. And in that talk, which is very, very long, so I don't even know if I wanted to recommend it to everyone, Hemming challenges people to ask themselves a question, and that is, in your domain of research, what is the most important problem that needs to be solved? And then he goes on and asks the next question, well, are you working on that? So I thought I'd ask myself the same question. Are we doing that? So for the next 3 slides, I changed the slide deck because I want to be very clear that I'm not representing an NI opinion here, but rather my own. I'm going to switch back from that. But the question remains, what are the big open issues in the realm of software-defined radio? And people have actually said, there are none left. People have said, SDR is finished. We're done. Like, we can move on, do something else. So SDR researchers can either be unemployed or do something else. And I disagree with that. But I know I'm not the only one, so I think I'm on solid grounds here. I think there are many interesting problems. But for the sake of this talk, I thought, why not just sit down and start writing some down? And so I made a list. Now, this list is the most opinionated, subjective slide in this deck, definitely. It's also not complete. And to be perfectly honest, I stopped writing when I reached the bottom of the slide. But I thought broadly categorized the following categories of problems, things that we will be working on in the SDR domain. First of all, hardware. Hardware, even though it's software-defined radio, we will always be talking about the hardware. How are we actually going to build SDRs going forward? Which components are we going to use? It's interesting. Can we even make hardware for all use cases? Or are there things that SDR simply cannot solve in the wireless domain? And even if we can do that, can we build one piece of hardware to do all of that? Or will we have a spectrum of those? Also, I think this is important. How can we make sure that we keep hardware accessible? You could argue this is a software thing, but I've just kept it in this category. But frameworks and software is maybe the biggest one, and also possibly, for my personal interest, also the most interesting one. Frameworks and software, I pose the following questions. Can the frameworks that we use keep up with the heterogeneity of hardware? And that is something I struggle with on a daily basis, at my day job at Ettus. Also, bandwidth requirements keep going up, and latency requirements get tighter and tighter, and all these things just get harder. And these are all problems that are traditionally hard to solve in software. Dealing with a lot of data in a very short amount of time is typically something we would rather have hardware do for us. So in the concept of frameworks, are we even, is this even something we can solve? I think even on the algorithmic side, we're not done yet. And you might disagree with me and say, well, no, algorithms have been figured out. This is easy. You can pose a maximum likelihood problem and just solve that, and that's that. But I think I disagree, because if you look at textbooks, even modern ones, many of the algorithms come out of a different era where you were dealing with digital hardware that had low memory available and that kind of thing. And I would argue, if I pose a very badly framed question, but with a lot of constraints, but soft constraints, such as resource utilization, power usage. So I give you many, many bars sort of error bars of dimensions and say, okay, like within this space, you go find the optimal algorithm. I don't think there is a scientific approach to that yet. The fourth category is a bit of an odd one out. I'm just going to talk about it still because I find it personally interesting and important. Like SDR is one of the most cross-functional areas of expertise that we have. Like you just need to know so many things to be effective in the domain of SDR. And I don't think that our educational institutions are perfectly equipped to educate that kind of engineer. Now, I mean, I know, like, I see a lot of you in this audience who fit that bill, but I also know that many people who came into SDI now know software and FPGAs and DSP and hardware and all those things sort of slipped into that more or less coincidentally, and not because they got a master's degree in SDR. And I think this is an example. What if you wanted to build a cell phone, you know, like one of these guys yourself, and you don't have 25 years of experience, but rather you're sort of just very interested, like, could you do that? And I think the answer is clearly yes, people have done that. And if you go to sites like Hackaday, et cetera, you will find people doing way more sophisticated stuff than this, even individuals. But still, you would run into all those problems I mentioned earlier. So, like, first of all, like, which hardware do you start working on? I mean, you're not going to build something in this form factor with the same kind of features. That's unlikely. But even if you just disregard any kind of space requirements, like, what do you actually pick? And then which software are you going to use? Like, you're not going to use GNU Radio, that's for sure. But why not? Like, why can't we get GNU Radio in that state? So you could use SRS UE, for example. That's perfectly fine. It's even open source. Like, but then you sort of go away from that framework paradigm where you have like a monolithic piece of software, even if it's very well written. And I still think that's a step up from hardware-defined radio, but it's not a step towards sort of a fully modular approach to a software-defined radio, and so on, and so on. So let's go back to my little list and go to Hamming's second question, which is, well, are you actually working on the most important things? Now, we're not solving all the problems of SDR at Ettus or National Instruments, but we are working on some of them, and I think they broadly fall into the first two categories, so I'm going to talk about that a little. I'm sort of going to take it back to a proper sponsor talk and see how we plug into this domain. First of all, let's do some general hardware trends. If you look at what's going on out there in the world of hardware, very interesting things going on. There's a whole bunch of companies that are actually, doing stuff that is not just faster and bigger, but it's actually, more, really new ideas in there. Xilinx and Intel, NVIDIA, analog devices, and even Fujitsu is like, this is a random chip I recently stumbled across, but it's sort of a very non-traditional architecture to do, in this case, digital annealing. Like all these things are coming out, and I think we need to sort of think about how we can integrate those into an SDR concept. And what's really interesting, I think, is that we have certain theoretical or software developments happening that are actually driving hardware development. So, years and years ago, like TensorFlow was released, but then 2 years ago, someone said, how about we just build a chip to accelerate that specific problem? So I think machine learning in general is driving a lot of these things. So none of this is obviously Ettus related, but we are looking at all of this. But what we are doing is we're building SDR devices. And the philosophy that we've always had is, well, we'll just accept the fact that we can't build a device that has infinite performance and zero cost. But we'll accept the fact that if you want something more powerful, it'll draw more power. So we say, OK, we'll just provide a whole spectrum of devices that sort of scale on this trade-off line where you sort of want more power while you need a bigger device. So we have a whole bunch of usurps, and I'm not going to go through all of them. These are sort of the most popular ones. I will plug two of these very briefly, though. The first one being the usurp N310, which was released early this year. And it's definitely an evolution of what we had before. It's a bit bigger than X310 and has some concepts of the E310. 7100 FPGA, so you can do lots of things. We use a AD9371 to achieve a higher channel count than we do on the X310. It has an SFP, so it does look a lot like an X310 on the outside. But I think what sets it apart is the fact that it's running in embedded Linux, that we've specifically geared to make it easier to manage and provide sort of more control features on the device itself. So basically turning it into a smarter device. And another usurp, oh, I'm sorry, yeah, this is available at the booth. I mean, it's not available for purchase directly at the booth, but you can go check it out, take a look at it. And another usurp that is in a similar sort of design philosophy is the E320, which we also, which this is not yet available for purchase, but it is basically done, and you can take a look at it at the booth as well. So this is somewhere between the E310 and the N310. So we sort of try and sort of fill the gaps in that spectrum I mentioned earlier. 7045 FPGA also has SFPs and a GPSCO, but also has an embedded Linux which we can use for control and command and all these kind of things. This is also at the booth, and also we'll be talking about more of it tomorrow. So I'm just going to stop talking about it right now. We've done a whole lot more development on the hardware side that is not specifically a new product. So simplifying good control of usurps is something we've been working on. We sort of had a better approach to the way we create the Linux distributions that run usurps using Open Embedded. And we install a whole bunch of tools such as SaltStack and Mender that enable remote management and telemetry, remote updates, that kind of thing. Let's talk about the, this is another interesting thing that we added recently. I just thought it was definitely worth a slide. We know how to synchronize usurps. We've been doing this for a long time. But what if they're very far apart? So we added White Rabbit to sort of the gamut of technologies that we use. White Rabbit is something that CERN produced, and we've incorporated it, which was very possible because they have an open source implementation. It's a technology that is Ethernet-based, and it allows us to synchronize usurps that are very far apart. So this picture here on the right is actually, the center right for those who don't see where I'm pointing, is actually from our knowledge base. And this is an experiment we actually ran. So we had a 5-kilometer reel of fiber, made sure that the devices that are, like in terms of fiber length, are 5 kilometers apart are still very well synchronized, and it works really well. N310 does implement this. Let's talk about software a little. So I do think that software and good frameworks and good accessibility to the SDR is like the key differentiator and the key enabler of like efficient development. So we can just build great hardware, and people can also write programs in C if they want, but that's not, I think, what makes SDR so successful. I think the ability to just plug stuff together and quickly prototype and then also deploy applications is really the key feature. And there are plenty of SDR frameworks out there, and both open and proprietary. Obviously, we all know GNU Radio. Like 2 others I've sort of put screenshots here on are like the MATLAB solution, and of course, National Instruments has also a LabVIEW-based solution for doing wireless communications. These are all very, very different. And I mean, they all have different backgrounds too, where GNU Radio, someone sat down and said, OK, I want to build an SDR framework. And whereas like the MathWorks said, well, we have our tool, and now we want to do SDR. So, but for various reasons, these are very different. And what I have not yet seen is sort of a scientific approach, like analysis of these frameworks. Say, well, why are they so different? And what do we actually need? How can we improve them? And I do think this is something where there is a lot of interesting research to be done. And if you're sort of involved in the GNU Radio runtime, we talk about scheduling all the time. And you'd think like after 60 years or so of computer science, this is a solved problem. How do we schedule algorithms and blocks? But it's not. Like this is still something that we're trying to figure out. So what are we doing in this domain? First of all, we kind of hedge our bets a little and say, well, we'll just make an API that can run anywhere. So C, C++, Python APIs are available for UHD. So that's a bit of a cop-out solution to the problem, but it still makes sure that we can easily be integrated. There is a talk about the UHD Python API, which is now in stable UHD, so I'm not going to go into that in any more detail. Sorry, when is the actual Python API talk? Is it on Thursday? Thursday, OK. But I do want to talk about RFNOC, because this is our sort of big framework solution to the that we're sort of implementing. Now, for those who haven't heard about it, in a nutshell, it is our solution to natively support FPGA acceleration within usurps, but within the framework paradigm. So this is a very modular approach. You can quickly, well, depending how well-versed you are in FPGAs, but you can plug your algorithms together in a modular fashion. There is always some framework overhead with any kind of framework. Same is true for us. In our case, it's FPGA utilization. But you can create these kind of heterogeneous applications where you mix and match GNU Radio and FPGA and have like software and FPGA co-processing, which is pretty cool. Now you might say, well, Ettus guys, you haven't really been that active on the RFNOC development side in the last year. And I would have to admit, yes, we have not. We've been busy with the other usurps. But we are definitely back on track with that. And this is a statement I can always make. We will use RFNOC as the core architecture for our usurp. So we are 100% committed, invested in this project. And as sort of a proof of our continued development, we actually have a new demo up today. I think it's up today at the booth. This is an RFNOC-based RF loopback without host involvement. We turned it into a ham repeater on some UHF frequency that I don't know off by heart. So you can see that at the booth. Talking about RFNOC, there are tutorials, 3 of them this week. And last I heard in the AM break, there were still some slots in the Monday or Tuesday talk. And you can go talk to Neil if you're interested in joining one of those. And we will be working on this. And the next thing that we need to do is actually stabilize our APIs to make sure that people can use them. How am I doing on time? I lost track. 10 minutes? Oh, OK, plenty. OK, that's so. Like I said, go check this out at the booth. And also, if you're interested, take a look at the tutorials. This is a little very specific project, but it's something I thought that was worth mentioning. I talked about higher bandwidth requirements, and that's obviously something that we have to deal with. So we want to pull more and more samples into a CPU in the same amount of time, or even shorter amounts of time. So we started researching a library called DPDK. So DPDK is not something that we wrote. It's available, but we're researching integrating that into UHD. And some of you have figured that out by sort of checking our Git logs. So I thought I'd mention it today. So we don't have any kind of stable device support or benchmarks yet. There is Alex Williams over there is our expert in DPDK and fast processing, so you can talk to him if you like. This is something that we'll be using to sort of improve the overall throughput. And the general gist of this library is that we pull Ethernet handling that is typically handled in the kernel into the same application where we process the packets. And that means we have more knobs and dials to optimize throughput and thus eke out a few more samples per second. I have 10 more minutes. Wow, I think I went a little fast because I'm already sort of in the final phase of this talk. Because I had this long list, and then I had like a subset of that list. I said were things that we are working on at Ettus Research. So what about the rest? So I mean, we can build great usurps. That's what we do. But great usurps aren't going to train the next generation of SDR engineers. Even if we have a library that is like open and you can check out the code. So code both on the FPGA and on the host side for sort of for learning perspective. But that's not really our sort of key business, nor will they create the perfect algorithms, or we're also not in the chips business. So who's going to do all of that then if we want to reach a place where sort of the actual relevant problems of the SDR domain have been solved? And I think the people who will actually do all these other bits are you guys, so the attendants of this conference. And like-minded people, of course. So, this is actually going to be my segue into my concluding slide. Like I said, we are committed to building SDR devices, and we'll try our very best to make the best hardware and software that we can to help solve these problems. But if I look around here, then I see a lot of I've already had so many interesting conversations just today about people, what they've been doing, and like the few talks that we've already had have been very interesting. So I look around and I see people who are actually working on all these interesting problems in the domain of SDR. And I'm very, very excited to see where this is going, and I'm very happy to have more conversations and talks with you guys about what's happening. So yeah, to wrap it up, this is me being excited. We'll provide the usurps, and you can provide everything else. And I think we'll have a very interesting future ahead of us. Thanks.
Thank you, Martin. All right, so do we have any questions from the audience? Yep.
I was wondering how your DPDK framework compares with the remote direct memory access, in which you're pushing all the internet commands from the kernel directly to the NIC.
Okay, so if you want to know the nitty-gritty details of DPDK, I highly recommend talking to Alex over there, who was our expert. But I will give you a high-level answer to that. So you said remote memory access.
Remote direct memory access.
Right, that's not what that does, because we still go over the network. What we do is we take the handling of, say, the network layers and UDP handling and all of that out of the kernel, put it into the application where the packets are being processed, and what that saves us is context switches between user land and kernel. And those are a key performance hit. So the NIC still does the first step, gets the packet, and then flags an interrupt or something. But then we mostly bypass the kernel, go straight into a UHD application, and then do whatever we want from there. So we could then move packets to memory or whatever we want to do. And I don't know how familiar you are with the current UHD paradigm, but the standard model is you would then make a copy to receive just the raw samples in your user applications. We can still do that, but we could do that a little faster.
Other questions? What's up, Trip? Thanks, Derek.
Hey, so there's kind of this trend where everything has a Zinc now. Do you see everything having an embedded processor and an FPGA going on into the future?
So I mentioned that we have a spectrum of usurps for different use cases, and I think there are still going to be use cases where you don't need that, because there is a lot of overhead with having a whole operating system on your device. I think for the higher end devices, it makes a lot of sense, because I talked about this in more depth last year. There are just so many tasks that we can just hand off to the device that way. But for the lowest cost and lowest power, I think you would not want to do that. So yeah, and that's one of the questions that I pose. What will the actual hardware devices look like? And I think that's one of the reasons we will probably not just have one piece of hardware that can do everything. So having the Zinc is very useful. I mean, you can just run the entire application on the Zinc too. You don't have to stream samples off device. You can just keep your application on the device itself, and then have an effectively headless application, which with an X310 would be a lot harder to pull off, because you'd have to do all the management on the FPGA.
Other questions? Nope. What's up, Ian?
He's gonna troll me.
Oh
again.
man, you're gonna get nailed to the wall, Martin.
Hey, Martin. Hey, so you raised a point that's a real thing that always riles me up. You sort of pointed at a smartphone and said, how do we make a software radio that's in this form factor? And this always riles me, of course, because every one of these is a software radio.
Okay, I was kind of expecting that question, so I'm a little bit off the hook here. Yeah, first of all, the point I was trying to make was you take two N310s and you have fans blowing, and then you achieve the same kind of functionality as this. Seems a little underwhelming, right? That's really where I was going. And yeah, of course, you're right. Software is going everywhere, including smartphones. But I think there is you can make the case that anything that has software is a software-defined radio. But I have sort of a more constrained definition of that, where you not only have but basically, you have a generic software access to everything, and that's not true for a phone. That's simply not the case.
I mean, the real obstacle is that the guys who make the chips in these are very much private commercial entities, right? And they don't want the support load of a general-purpose research audience. They want 5 or 6 customers who justify the enormous amount of support it takes, right?
Yeah.
But
and like I said, maybe SDR is not the answer to everything. And one of the reasons we use SDR, say as academic users, is because we have one-off type applications, and I don't know how many billions smartphones are on the there's a whole different kind of economical what's the word I'm looking for? Incentive here, right? So you can also throw thousands of people. You don't even need that cross-functional training that I talked about earlier. It's fine. You just hire 1,000 people, and then you have all the skills in those 1,000 people. But I think we can do better. And one of the things I really like about this conference is people show up and they're like hobbyists, and they have I built this completely ridiculous application that puts all of you big businesses and government labs to shame, where you spent $1 million, I spent 1,000. That's the kind of thing we can achieve with SDR. Maybe someone will actually build a smartphone from SDR components that is actually about the same price point as one of those Samsung ones. And at that point, Samsung will look really silly. I'm not saying I mean them any harm or anything, but I would be a little happy when I see that day.
Other questions from the audience? Oh, Yuha.
I have a question about your products, your future products. I was a really big fan of the USRP1 when it came out. I really liked USRP2. And I liked them because they were very simple. Basically, an ADC and a DAC that was hooked to your computer. Are you still going to keep making such devices?
Well, I'm not going to say anything about future product development because I will be the one that's on the hook then. Like I said, we have a spectrum that we want to address, and we'll have sort of the low-end stuff that is cheaper, and we'll have sort of the high-end stuff that's more complicated. I mean, one thing that I do want to sort of point out is as we sort of try and push the boundaries, things get more and more difficult. And DPDK is an example. It's assuming we would have a product that had DPDK support, just the installation of all the software and the configuration would be already significantly harder, because now you have to go into your system and configure things. And I mean, we're not and that's where we sort of recently put all of our focus. So I'm sort of trying to avoid your question really, as you may have noticed.
The reason why I'm asking is that a lot of our instruments that we've developed depend on the N200, for example. Is it going to be discontinued at some point, or are you still going to keep cranking them out?
I didn't understand the last one.
Are you still going to discontinue the N200, for example, at some point in the near future?
I don't know.
Because a lot of the instruments that we've developed depend on it. And
I mean, it's unlikely that we will discontinue something that is doing well. At some point, we run into a problem such as parts get discontinued, and we would have to basically launch a new R&D project to sort of actively continue. We're not going around killing products, right? But if we had to redesign the N200, would we do that today? I can't answer that question. It's hard. But I even as an enthusiast, I really like my B200 Mini. I have one of my own too. It's just tiny. It's I don't have to deal with any kind of setup. Whatever OS people have, it'll just work. I totally understand that kind of appeal. I'm very happy that we managed to sort of keep the same APIs, span the whole spectrum of devices so far. But I think if we want to push the high limits, this will get more and more complicated. And the low end, I haven't really prepared a good response for that. Sorry, there's not a great answer to your question, but I can understand the appeal. I just don't have a good answer for you right now.
Other questions?
Yeah, just to follow up on the last question. Sorry.
Yeah, go ahead.
But I think basic devices have a really important role for those that are trying to break into the field. Because the learning curve is steep enough anyway. And so add the complexity of FPGAs and that kind of thing. I think it's I just think it'll be advantageous for students and people just moving into the field to just give them a simple device that could be, that can be programmed simply.
Yeah, marketing folks, write that down.
All right, let's thank our speaker. Thank you, Mark.